Hello student, this is Darasa Online. My name is Edgar Mshana. I'm teaching advanced mathematics. Today we are going to discuss the topic of numerical methods. And in this part of numerical method, we have the subtopics of one, that is numerical integrations, where we are going to discuss the trapezium rule, which is sometimes is called trapezoidal rule. But the second one is Simpson's rule. So students, we are starting with trapezium rule. As I said earlier, sometimes it's called trapezoidal rule. Let us see how are we going to derive this rule. So suppose we want to find the area under this cave. That is the same as the integral. By using our limit, that is from a to b, then we integrate our function. So in this case, you can find with a number of y's here, with y1 up to y6. These are called the number of ordinates. But sometimes we use the number of strips or number of intervals instead of number of ordinates. We are going to see how they differ. So the number of ordinates or the number of strips, that is the number of strips or intervals is given by, that is h is equal to b minus a over n. That is how to find the number of strips or the number of intervals. But for the case of ordinate, we say the number of ordinates, the number of ordinates is given by, that is h is equal to b minus a over n minus 1. So dear students, you can see the difference between number of strips or intervals and the number of ordinates. For the case of number of strips or interval, just take b minus a over n, where b, that is the upper limit, and the a, that is the lower limit divided by n. But for the case of number of ordinates, just take b minus a over n minus 1. So, my dear students, suppose we want to find the area under this cave, with the cave that is given by y is equal to f of x. In this case, we say, that is, suppose we want to estimate the area under the cave, that is under the cave, f of x is equal to y, or y is equal to f of x. We are saying area is equal to the integral from a to b, f of x dx will be the same as the area of this trapezium. Because if here we draw the straight line at the top of this ordinate, we are going to have the number of trapezium. So if we draw a straight line at the top of this ordinate, we are going to have the number of trapezium. That is why it's called trapezium rule. And you know the area of the trapezium. So let's take, if we want to find the area between y1 and y2, that is for the first trapezium. That will be the same as 1 over 2 h, then y1 plus y2. That is for the first trapezium. for the second trapezium will be between y2 and y3. So in this case, we are going to have plus a half h. This time is y2 plus y3. So again, my dear student, we proceed with the third trapezium. That is a half plus a half h y3 plus y4. Then again, it will be a half h y5 plus y6. That is how we are computing the area of this trapezium. Then once you open the bracket and simplifying, we are going to have the following general formula. So on simplifying, that is on opening the brackets and the simplifying, we have, that is, area is equal to integral from a to b f of x dx is equal to, so 1 over 2h, that is common to all items. So that is 1 over 2h bracket of, then here we have the first ordinate, that is 1, but the last ordinate, that is y6. So it will be y1 plus y6. Then others will be twice. So then plus twice the remaining ordinate, that is y2, y3, y4, y and y5. So this is what is called the trapezium or trapezoidal rule. So this we call, that is this is called the trapezium rule. Or in summary, we say, that is in summary, or in summary, or we say area, that is area is equal to integral from a to b f of x dx is equal to 1 over 2h bracket of, here we just say sum of the first ordinate, sum of the first and the last ordinate, then plus twice sum of the remaining ordinate. So this will depend with the number of ordinates. So my dear students, let us proceed with the second rule, that is called the Simpson's rule. Students, here we have a curve that is a quadratic function. It's given by ax squared plus bx plus c. And this is our curve. And in this curve, there are 3 coordinates. The first coordinate, that is negative h, y1. And the second coordinate is 0, y2. And the last coordinate, that is h, y3. So let us substitute these coordinates in our quadratic function. That is substitute the 3 coordinates in the cave, y is equal to ax squared plus bx plus c. So in this case, for the first coordinate, that is the negative h comma y1, that is at negative h comma y1, we are going to have the following. That is y1 is equal to, then we substitute the value of x, that is the negative h. So negative h squared, that is a h squared. Then we have negative h times bx, that is negative bh, then plus c. But again, for the second coordinate, that is at 0 comma y2, that is at 0 comma y2, we are going to have y2 is equal to, in this case we substitute the value of x, which is 0, so it will be 0 plus 0, then plus c, so to be equals to c. Then for the last coordinate, that is at h comma y3, we are going to have y3 is equal to, so value of x is h, substitute in our quadratic function. So we are going to have a h squared, then this time is plus bh, then plus c. So in this case, we have three equations. That is, we have 1, but again we have 2, and we have 3. Now suppose we add y1 and y3. That is, just say add, that is add y1 and y3. In this case, we are going to have y1 plus y3 is equal to, now the expression for y1 is a h squared minus bh plus c, then plus ah squared plus bh, then plus c. Now in this case, we have negative bh, that will be cancelled with the positive bh. So we are going to remain with y1 plus y3 is equal to, now here we have ah squared plus ah squared, that is twice ah squared. Then again plus, we have c plus c, that is 2c. But remember, in equation 2, c is equal to y2. So here we say, but c is equal to y2. So here we have y1 plus y3 is equal to 2ah squared plus 2y2. Now let us make 2ah squared the subject. So we are going to have, that is 2ah squared is equal to y1, then plus y3 minus 2y2. So maybe call this is equation 4. So again, my dear student, you remember that method of finding the area under the cave by the integration. So by integration, we say the area under the cave, that is area is equal to integral from a to b, then f of x dx. But our function is a quadratic function. So in this case, area is equal to integral from negative h to h, ax squared plus bx plus c, this is dx. Now let us integrate our function. So we are going to have a over 3 x cubic plus b over 2 x squared plus cx. But the interval is from negative h to h. Now in this case, we have, if we substitute h in our expression, it will be a over 3, then h cubic, again plus b over 2 h squared, then plus c h. So this one minus, now substituting the lower limit, that is a over 3 h cubic. Now this time it will be plus b over 2, again h squared, minus c h. I'm sure you remember the meaning of h. H, that is the number of strips or intervals. Or sometimes we are saying h is equal to number of ordinates. Here in this case, we have a over 3 h cubic minus a over 3 h cubic. That will be twice over 3 a h cubic. So again here we have b over 2h squared minus b over 2h squared, that is 0. And the ch minus ch, that is twice ch. So in this case we have the area, that is area of our cave. But let us modify this area. So here we just say, on make modification, we are going to have 1 over 3 h bracket of, then here we are going to remain with 2a, then h squared plus, now here it will be 6c. So that is our area. But remember, here we have another equation, that is 2ah squared is equal to y1 plus y3 minus 2y2. So in this case, we can substitute the value of 2ah squared instead of writing this one. It's going to be replaced by, that is y1 plus y3 minus 2y2. So in this case, we say substitute equation 4 into equation 5. That is substitute equation 4 into equation 5. So in this case, we are going to have area is equal to 1 over 3h bracket of, now here we have 2ah squared, that will be replaced by y1 plus y3 minus 2y2, then proceed with plus 6c, that's plus 6c. But you remember the value of c here, but c is equal to y2. So in this case, we have 1 over 3h bracket of y1 plus y3 minus 2y2, then plus 6y2. So here we are going to have 1 over 3 h bracket of y1 plus y3. So here we have negative 2y2 plus 6y2. That is 4y2. So in rearranging this, we say now area of the cave, that is area, is equal to 1 over 3h bracket of y1 plus 4y2 plus y3. That will be the area of the cave for 3 ordinates. So this we say is the area, that is the area under the cave for 3 ordinates. Now, what about if you have more than 3 ordinates? Let's say you have 7 ordinates. What will be the formula of estimating the area under the cave? For 7 ordinates, that is for 7 ordinates, that will be as follows. So this is for 7 ordinates. For 3 ordinates, the area is equal to 1 over 3h y1 plus 4y2 plus y3. So the area under the cave for 7 ordinates, it will be, now area is equal to, so our starting point, we are starting with the 3 ordinates. That is 1 over 3h. Then we have y1 plus 4y2, then plus y3. Then again, proceed with 1 over 3h bracket of, now our starting point is y3. Now we have y3, then plus 4y4, then plus y5. So then again, plus, that is 1 over 3h bracket of, now we ended with y5. So proceed with y5, then plus 4y6, then plus y7, which is our last ordinate. Now in this case, we open up the bracket and collecting the related terms. Therefore area, in this case, we are going to have area is equal to, now here 1 over 3h is common. So this one will be out of the bracket. Then times, now here we have the first ordinate and the last ordinate. That is y1 plus y7. Then again we have the even ordinate. That will be 4 times. Now we can count the number of even ordinate. So in this case we have y2. Then again we have y4. That is plus y4. So the last one is y6. That is plus y6. Then again we have the ordinates. So here we add 2 times. Now number of odd ordinates. Our starting point is y3. Then plus. The next is y5. So this is the area under the cave for 7 ordinates. Now in this case we say that is area. Now area is equal to 1 over 3h bracket of y1 plus y7, then plus 4. We have even ordinates, y2, y4, y6, then plus 2, ordinates, we have y3 and y5. So this is called, this is the Simpson's rule for 7 ordinates. And of course, in summary, we say, that is in summary, we say area under the curve is equal to 1/3 h bracket of, so here we take the first ordinate plus the last ordinate. So here we say sum, that is take sum of the first and the last ordinates, then plus we have 4 times even ordinate, so that is 4 times sum of even ordinates, and then plus twice the sum of odd ordinate, that is twice sum of odd ordinates. So in this case, we have the general formula of finding the area under the curve, that is by what we call the Simpson's rule. So my dear student, now let us start doing the review questions. So my dear student, here we have the review question number 1. That is, use trapezium and Simpson's rule to evaluate the integral of e power negative x from 0.1 to 0.5, where we are supposed to use 5 ordinates, giving your answers to 4 decimal places. So remember, the number of ordinates, that is n. N is the same as the number of strips. But if we have given the number of ordinates, you just take the number of ordinates minus 1. Therefore, in this question, let us start with h. So we have to find the value of h. Remember, h is equal to b minus a over, that is n minus 1. Why n minus 1? Because we have been given the number of ordinates, that is 5 ordinates. So this one will be the same as, that is h is equal to, so b is our upper limit, that is 0.5. So here we have 0.5 minus, then we have a. So a, that is the lower limit, that is 0.1. Then over, then we have n minus 1. So n, that is 5. Just take 5 minus 1. So in this case, we are going to have h is equal to, that is 0.4 over 4, which is equal to 0.1. Now we have h. So now let us create a table that will help us to evaluate this integral. So just a simple table that is starting with x. So our function, that is a exponent negative x. So here we have, that is y is equal to e raised to negative x. So where is our starting point, my dear student? Our starting point, we are starting with 0.1. That is the lower limit. So we are starting with, that is 0.1. That is our starting point. Then we go for the interval of 0.1. So that is 0.1 times 2, that will be 0.2. Then the next, that is 0.1 times 3. We are going to have 0.3. In this case, the next will be 0.4. And the last one will be 0.5. Because 0.5, that is our upper limit, and according to our integral. So now we can find the value of y by using our function. So our function is equal to e raised to negative x. So we just substitute the value of x in our function. In this case, we are going to have the following result. For 0.1, that will be 0.90, then 480. Again, for 0.2, we are going to have 0.8187. Then the next, that is 0.3, we are going to have 0.74080. Then we have 0.4, that is 0.6703. And for the last one, that is 0.5, we are going to have 0.6065. So now it is time to apply the trapezoidal rule. That is starting with 1, that is by trapezium rule. Remember, trapezium rule the same as trapezoidal rule. We are saying area under the curve is equal to, that is h over 2. My dear student, here we just take the first ordinate plus the last ordinate. That is y1 plus yn. So yn, that is our last ordinate. So this one plus twice times the remaining ordinate. So here just 2 times the remaining ordinate. So in this case, we are going to have, that is h. So here h is equal to 0.1. So that is 0.1 over 2 bracket of, then we have y1 plus yn. Of course, this one will be our y1, and the last one, that is yn. So that is 0.9048 plus the last ordinate, that is 0.6065. Then followed by twice times the sum of the remaining ordinate. Now what are the remaining ordinate? Here we have y2, y3, and y4. Those are the remaining ordinates. So in this case, we are going to have 0.8187 that is 0.8187 plus, then the next is 0.7408, and the last one will be y4, that is 0.6703. So we close the brackets. So it's just a matter of taking your calculator and do this computation. So in this case, we are going to have, that is 0.29 85. Remember, we maintain the number of decimal places. So here that is 2, 4 decimal places. So my dear student, I think you are together. Now let us proceed with the Simpson's rule. So we are going to use the same table to compute the area of our cave, but this time we use the Simpson rule as we have already discussed it. So that is by Simpson's rule. So my dear student, remember the general formula for computing the area of the cave by the Simpson's rule. You say that area of the cave is equal to, this time is h over 3. Again, we take the first ordinate plus the last ordinate. That is y1 plus yn, then followed by 4 times the even ordinate. That is 4, that is sum of even ordinate. Then plus twice. So this time we add the odd ordinate. That is twice the sum of odd ordinates. So remember the value of h, that was 0.1. So here we have 0.1 over 3. So y1 plus yn, our y1 is 0.9048 plus yn, our last ordinate, that is 0.6065. So we have 0.6065, then followed by 4 times the sum of even ordinate. Now what are the even ordinate? Here we are just taking the even numbers. We have y2 and the y4. So y2, that is 0.8187 plus y4, that is 0.6703. Then the last one is twice odd ordinates. So that is twice the sum of odd ordinates. So we are having only one, that is 2, because we go up to 5. So 5 already used it, so we have only y3. Okay, so student, we proceed with the odd ordinates. Remember, for odd ordinates, we just take 2 times the sum of odd ordinates. Now what are the odd ordinates here? We have only one data. That is twice or 2 times 0.74080. So we just close the bracket. So it's just a matter now of taking your calculator and find the final answer. So what is the final answer according to Simpson's rule? So now area of the cave will be equals to, this time we have 0.2983. Again, we maintain the number of decimal places, that is 2, 4 decimal places. So my dear student, I think you are enjoying the lesson. Let us proceed with the second review question. Dear student, we proceed with the second review question. Again, we have to evaluate the integral of e power x squared from 0 up to 1 using trapezium and the Simpson's rule. And we are supposed to round our calculation to 4 decimal places. And this time we have 4 strips. So remember, student, we are following the same procedure as we did for the first review question. So solution for this review question. Remember, we are starting with the computing h, finding h. So remember h, this is equal to b minus a over n. We just divide by n because this time we have the number of strips, not the number of ordinates. For the number of ordinates, we just take n minus 1 as we did for the first review question. But here we have the number of strips. So we just divide by n. So n represent the number of strips. So h will be equals to, so b, that is our upper limit, which is equal to 1. So here just take 1 minus a that is lower limit, which is equal to 0, minus 0, over any number of strips, which is equal to 4. So this will be equals to 1 over 4. So our h, my dear student, this h is equal to 1 over 4. So you can write in decimal places, which is the same as 0.25. Now we have h. The next step, we can create a simple table. That is our simple table. We are going to have x. But again, our function, that is y, is equal to e exponent x squared. So, what is our starting point? We are starting with 0, that is the lower limit. So that is our starting point. So here we start with 0. The next is, we are using the interval of 0.25. So the next will be 0.25. That means we add 0.25 again, we are going to have 0.5. So 0.5 plus 0.25, because that is our interval, we are going to have 0.75. Remember, the upper limit is 1. So we add until we reach 1. That is the upper limit. So again, 0.75 plus 0.25. So we are going to have 1. So this time we have 1, which is the upper limit. So now it is time to find the value of y by using our function, that is e exponent x squared. So we just take 0. That is e raised to 0 squared. E raised to 0 squared is the same as e raised to 0, or e power 0. So e power 0 in this case, we are going to have 1. Well, that will be 1. You can put in decimal places. Maybe you can add zeros. Okay? So we proceed with 0.25. That is e raised to 0.25 squared. So just use your calculator, your scientific calculator. So in this case, we are going to have 1.0645. So the next we have 0.5. So again, you substitute 0.5 here. That will be e exponent 0.5 squared. So again, by using a calculator, you are going to have 1.2840. So you do the same for 0.75 and 1. So in this case, we are going to have 1.7551. And the last one will be 2.7183. Now, my dear students, after this, it is time to compute the area by using the two rules. We are starting with trapezium rule. So the first rule, that is by trapezium rule. I'm sure you remember the formula. That is area is equal to h over 2 bracket of, that is y1 plus. Now to avoid confusion, you can name these strips. That is starting with y1, that is, we have y1, then we have y2, y3, y4, and y5. Just name them to avoid confusion. So in this case, we have y1 plus y5 because we are taking the first ordinate plus the last ordinate. Then followed by twice sum of the remaining. Here we take sum of the remaining. So here that is sum of the remaining ordinates. So that is, so our h, remember, is 0.25. So here we have 0.25 over 2 bracket of, then we have y1 plus y5. y1 is equal to 1 plus, then y5 we have 2.7183 plus twice times the remaining ordinates. What are the remaining ordinates? We have y2 which is equal to 1.0645 plus the next we have, that is y3. So we are going to have 1.2840, then plus y4, this one, which is 1.7551. So in this case, you can take your calculator again to compute the area by using the approach of trapezium rule. So in this case, we are going to have area is equal to, so this time we have 1.4907. But again, the number of decimal places is 4. Of course, here we have 4 number of decimal places. That is 4 decimal places. So that is trapezium rule. So my dear student, let us proceed with the Simpson's rule, the same question. So that is by using the Simpson's rule, which says area is equal to h over 3, that is h over 3. Then we have y1 plus, now the last ordinate, that is y5. Yes, add y5. That is the first ordinate plus the last ordinate. Then followed by 4 times sum of the even, that is even ordinates. And the last one, that is 2, then sum of odd, ordinates. So that is the Simpson's rule. So remember the value of h is equal to 0.25. So we have 0 0.25 over 3. Take the first ordinate and the last ordinate. We have 1 plus the last ordinate is 2.7, 183, then plus 4. Now starting with even ordinate. What are the even ordinate? We have y2 and y4. So y2 is 1.0645 plus, that is y4, we have 1.7551. Then plus, according to our formula, is 2, the sum of odd ordinates. So we have 2. What are the odd ordinates here? We have only one, that is y3. So y3 is 1.2840. So in this case, again, you just take your calculator and compute what is here. So in this case, I'm sure you are going to get the following answer, which is 1.4637. That is 2 4 decimal places. So my dear students, you have seen how trapezium rule differ from Simpson rule, but all of them, they are making approximation of finding the area of the given cave. And of course you can see the answers. For the case of trapezium rule, we have 1.4907, which actually is the same as 1.4, this is 637. Somehow they are the same because it's just a matter of approximation. They are making approximation of the given cave. So my dear student, it is my hope that you're learning something about numerical integration. So my dear student, here there is assignment for you. It's your time to practice using the trapezium rule and the Simpson's rule. So the first question, that is your assignment. Apply trapezoidal rule with the 5 ordinates to obtain an approximation for the integral. Here we have the integral of 1 over 1 plus x. The interval is from 0 to 1. I'm sure you know the meaning of ordinate. When they are talking about ordinate, remember to minus 1. Just take n minus 1. So what is n? N is 5. Just take 5 minus 1. That is very important for you. So again, my dear student, we have the second assignment question for you. That is, use trapezoidal rule to find the approximate value of the following, given the number of strips is 4. With the integral from 0 to pi, square root of sine theta d theta. So this time we have the number of strips. So when you have the number of strips, we just divide by 4. There is no need of taking away 1. So even this one, it will be easier for you to compute or to estimate or to approximate the area of this cave. And the last assignment question for you, that is 3. That is assignment number 3. Use the most accurate method of the numerical integration to evaluate the integral using 5 ordinates. This time we have the integral of from 1 to 3 ln x squared over x dx. So what is the most accurate method among the two? the Simpson's rule is the most accurate compared to the trapezium rule. So in this case, you are going to use only one rule, that is the Simpson rules. So you are going to use the rule to approximate the area of this question. My dear student, I'm sure you've enjoyed much in this lesson of numerical integration. And it is my hope that you will never miss this lesson of advanced mathematics. I wish you all the best in your studying when you are at home. Till next time. Thank you.